All right, so today it's a lot of equation solving, and that'll feel good to you because you probably are pretty good at solving equations. You've been doing them since 7th grade. You know, you always start with something like this, and then how would I start? Subtract 7. And do you have to show this minus 7 on both sides? No, but you do have to show what results after your first step. So 2x equals, take away the 7, and you got what? 6? Okay. You'd have to show me at least a step of work like that. And then do you have to show divide by 2, divide by 2? No, you can just go right to the answer. But my point is you have to show some work. You don't have to show every single step. Okay? All right. So that one, it ends up coming out to x equals 3. Notice that it gets smaller and smaller over time. And that's ideal. If I have a big equation, I want to just make it simpler and simpler and simpler and simpler. And at the end, you get the answer. Okay. So lots of distributive on the test that you're going to have. So you're going to have to be able to be really careful about remembering to distribute out the 3 or whatever, or the 2 in this case. And you'll have to know when you can drop parentheses and when you can't. There is a typical problem. Would you write that one down? I have no problem with you eating goldfish, but I want you to be with me at the same time. If it comes to a choice between the two, I have to win. All right, now we're going to multiply the puppy out. So 2x, and then don't forget the 2 times the 3, so 2x plus 6. And can I just drop those parentheses and say negative x plus 4? I have to distribute the negative. That negative has to go to both of them. Negative x minus 4. And now, next step, you could get rid of the 2x on both sides by subtracting 2x if you wanted to, but we could also put these guys together. We could put these guys together. They're called like terms. There's a lot of things you could do. What do you think is what do you think is a good idea to do first? Add the things together. Let's put this and this together. What does that make? X. And what's that and that make? 2. So x plus 2 equals 2x. Now, variables on both sides. You have to be a pro at that. You got to get rid of one of them. So what you do is you get rid of the smaller one. Which one's smaller? The x. So I take away the x. And now I have 2 equals 2x minus an x. It's not 2. Think of it as 2x minus 1x, and you get an x. So x equals 2. There we go. There is a typical solve equations question. Does that feel comfortable? You good at that? Okay, because if you're not good at that, this is going to be a hard year. I'm not saying you wouldn't make a mistake, but because this is like basic algebra stuff, and we're moving way up above that. All right. So variables on both sides, we already talked about that, but let me give you a little more complicated one. Let's say it's 3x minus 5 equals negative 9x plus 10. Solve that one. It's got variables on both sides. That's its main problem. I think you're going to see me drink a lot of tea this year. My theory is that human beings should react similar to mice. They took like a dozen mice and another dozen mice. One set of mice, mice A, they let them drink a normal amount of water and food. Mice B, you might say, didn't get any water for their entire life. They only got tea and their food. Same amount of food, same kind of food. And of the 2 sets of mice, the ones that drank the tea lived 20% longer and had like 20% less cancer and all the other nasty things that can happen to you as you get older. So they lived longer and they had less diseases just because they drank tea versus water. Does that mean I'm going to never drink water? No, but if I can throw some tea in now and then, it'd probably make me live longer. And it might be not exactly 20%, but it was a pretty significant difference. And if you think about that in terms of a human life, if you normally have humans living to like 80 years old, what if it was 20% different? Think about 20% of 80. 10% of 80 would be 8. So 16, that'd be 16 years longer. So if it is true in humans like it is in mice, you might live 16 years longer drinking tea. Now, some of you might think, well, what do I care? When I'm 80, I hope I die anyways. Well, you know, some people really are. They're like, when I get that old, just get me out of here. But you'll also at least be acting like a 60-year-old when you're 80, which means, you know, if you're still healthy and everything, then it's good. I hope I just get hit by a bus when I'm really old, because it's not fun to have, well, I got to see my mom die recently, and let me tell you, it would have been so much better just get hit by a bus. Really, she would have picked it any day. Be awesome. But because it was tough, she couldn't breathe, and watching her not be able to breathe was really hard for me too. So anyway, it wasn't from smoking or anything like that. Although she did have, anyway, she had somebody in the house that smoked. So okay, back to happy thoughts, which in this case is variables. All right, I'm going to get rid of this one or this one. Well, you really can do either one. I personally would pick this one. Why? Because you get rid of the smaller one, and that is really smaller because it's negative. It's smaller. Now, the other way would have worked, but this is the smarter way. Why is it smarter? Because when I'm done with this, I have one less negative in my problem than if I would have subtracted 3x from both sides. It would have also worked, but I have more negatives. I don't like negatives. It cancels. Positive 10. I don't really need the plus in front of that. I know it's positive. And now from there, I'm just going to add 5 to both sides. And then the final answer would be 15/12. Not really. We do require, we're okay with you leaving improper fractions, but we require you to reduce them as far as you can. So 5 goes in here, 5 times 3, and that's not going to work. 5 doesn't go into both of them, but 3 goes into both of them. So 3 times 5 and 3 times 4. There we go. And then those can cancel. The answer is 5/4. Make sense? How many of you had that already? Okay, awesome. So how about if we have equations with 2 fractions to clear? All right, I made this up because I know what you have to know for the test, and I also know what you have on your worksheet. And so what if you got a couple fractions to clear? What if it's like 1/4 x plus 3/5 y equals 10? Notice how it's got a couple fractions in it? Can I find common denominators and add them and all that? Yes, but it's a real pain in the butt. So I'm going to show you an awesome way to get rid of all the fractions in your problem. You won't have fractions anymore. The way I'm going to show you is, you know what, I'm going to make life just a little simpler. Get rid of the y here. Just get rid of the y. We're going to have only one variable, because usually your problems that you'd have this in will only have one variable. All right, so how do I get rid of these fractions? I'll give you a hint. If I multiplied by 4, it would fix that fraction. Because if I multiply by 4, 1/4 times 4 will make that fraction disappear, right? Got an idea? Close. Multiplying by 4 over 1 is the reciprocal. So that's close, and I'll give you another hint. If I multiplied by 5, it would fix this one. So multiply by what in this case? Nope. Multiplying by 4 is good. Multiplying by 4 would be better than not multiplying by 4. Multiplying by 5 would be kind of good too, but come on, somebody put this together. Yes, multiply by 20. Because if you multiply by 20, it fixes both of them. Watch when I do it. Watch what happens. If I go 20 and I times by 20 and I times by 20, I can do that as long as I multiply everything by 20. Get how this and this have a factor that's in common so it can reduce and the denominator will disappear? And you get how the 20 and the 5 will have something in common so the denominator disappears? That's why we chose 20, because 5 times 4 is 20, and that is a number that they both could use. It's like the common denominator. You multiply by that all the way through the fraction. And then all of a sudden, what's 20 divided by 4? 5x. What's 20 divided by 5? 4. 4 times the 3? 12. Equals 20 times 10, 200. Isn't this a lot nicer because it doesn't have fractions anymore? Now you solve that and you'd have the answer. So getting rid of fractions is a really handy thing. All right, so let's say you had this. 3/4 x minus 5 equals 2. That's only got one fraction in it. Super easy. What are you going to multiply by? Multiply by 4 in all three parts. Go ahead, do it. Now, I know some of you are thinking, why don't I multiply by 4/3? Do you really want to have to multiply 5 times 4/3? It's pain. Don't do that. Just multiply by 4. Way easier. Times 4, times 4, times 4. Cancels. 3x minus 20 equals 8. And now from there, it should be easy peasy, right? Subtract 20 from, or add 20 to both sides, divide by 3, you're done. All right. One more like that. Let's say I have 3x over 5 plus 2/3 equals 1. Could you multiply by 4 or 5? Yes, but it would only solve one of your problems. Could you multiply by 3? Yeah, but it would only solve one part. So what are you going to multiply by? 15. And I like to do it this way, where I change my 15 into 5 times 3. And I change my 15 into 5 times 3. And then the cool part is, then lots of canceling. 3 times 3 makes 9x plus 5 times 2 is 10 equals 1 times 15 is 15. And now, from there, super easy. Subtract 10, divide by 9, done. You get that? Clearing fractions, it's called. You're going to use it several times in pre-calc. That's why we wanted to make sure you knew how to do that. It's basic algebra. Not saying you did it a lot last year. This is one of those times where you might have done it a different way last year, but this is a really good way. And the reason we're teaching it to you is because calc teachers love this way. They use this in calc all the time. So in pre-calc, we kind of get you used to it. All right. Inequalities with variables on both sides. Well, if I've got variables on both sides and I've got inequalities, what if I have like 2a plus 3 is less than 4a? What is going on this one? Well, my best hint to you on inequalities is act like they're not inequalities. I'm going to put a less than up here to remember what I had. And in the meantime, I'm just going to use a what, do you think? An equals. Just act like it's an equals and do it like it's an equals. Only at the very end do you have to worry about that sign. So I'm going to subtract 3. No, that'd be dumb. What should I do? Do the a's. Yep. Subtract 2a. You can also subtract 4a, but I like subtract the smaller one. Cancels. 3 equals 2a. Almost done. A has to be alone. Divide by 2. So 3 halves equals a. Except it's not equal to a, really. I go back up, and what sign was it really? A less than. There we go. Now, will that sign ever switch places? Yes. If during the course of the problem you ever multiply or divide by a negative, the sign has to switch. Let me give you an example. Let's say it was negative 2a equals 10. Let's see. Oh, you have a question on the last one? Okay. Let's say it was negative 2a is greater than 10. Okay? Remember, act like that's an equals and just solve it. Go ahead. Act like that's an equal sign and you can solve that. That's easy. All right. Comes out to a is equal to negative 5. Now we're supposed to go back and just put the sign in. But again, did I ever multiply or divide by a negative? Yeah, I divided by a negative. So then the sign has to switch. It goes that way now. And now let's just see why. Why is that true? A has to be less than negative 5. What's something less than negative 5? Think of it as a temperature. It's 5 below 0. What's something less than that? 6 below 0. Okay, so negative 6. So that means if I put in something like negative 6, it should work. Is this bigger than 10. Negative 2 times negative 6 makes positive 12. Is that bigger than 10? It works. Okay, so this has found all the things that are going to work for me. It's things that are less than negative 5. Negative 5 will be close. If I put in negative 5, it'll close to work. See, if I put in negative 5, it'll come out to positive 10, but 10 is not bigger than 10. See, so it doesn't exactly work. That's why we can't use that itself. But we have to have things that are less than negative 5. Yes, ma'am? Ooh, really good question. If you do the problem right, you should only divide once in the problem. Okay, so it's kind of a trick question. But if you did it in that way, where you got rid of a negative 2 by dividing by negative 2, and then later you had to get rid of a negative 5 by dividing by negative 5, then yes, you'd have to switch it twice. But I don't think that'll happen to any of you, because usually you only divide once. And usually it's because you combine those terms together and then you get rid of them. Know what I mean? Okay. All right. Good question, though. Never been asked that question. I like that. Solving literal equations. That's like E equals mc squared. This is a literal equation. It means there's lots of variables. It already is solved. It's solved for E, but it's not solved for M. If I wanted M to be alone, that is a typical question you have to be able to handle. Solve for M. Well, you just act like you're solving a normal equation. Act like these are numbers. Act like that's a number. If I want M alone, I got to get rid of that. How do I get rid of c squared? I divide by c squared because it's being multiplied right now, and that's the opposite. So I divide by c squared, divide by c squared. This cancels this. E divided by c squared equals M. I solved for M. Okay, here's another one that you've probably heard of. Force is equal to mass times acceleration. Have you seen that one before in science? All right. So, solve for A. Try it. Hey, I want to know what A is. F is MA, but what's A? So just act like it's an equation where you got to solve for A, get rid of the M. See how A is alone now? I solved for A. What's the answer? F over M. That is just as good as that other formula. Okay. What's another one? Surface area, which I'm just going to call S, is equal to 2 lengths plus 2 widths. That's a true statement, in a rectangle anyway. So what's W? Solve for W. Got to get the W alone. So first you ask yourself, what do I get rid of to get the W alone? You want it when you're done to say W equals. When they say solve for W, or they might even say, see what the directions say on those. Solve for the specified variable. So they might like say this and then say for W. It's kind of confusing. It looks like it's part of the equation, but it's just saying, here's an equation, solve it for W. So W equals is what they want. So how do I get W alone? I get rid of this first, so I subtract 2L. Remember, this 2L is being added. That's why we subtract it. Subtract 2L on both sides. These cancel. And I have S minus 2L equals 2W. Is W completely alone yet? No. Got to get rid of the what? So divide by 2. Divide by 2 here, divide by 2 here, divide by 2 there. And yes, you could have had one big divide by 2 there and it would have been okay. 2's cancel. Get how W is alone? Here we go. All right, so W is equal to S over 2 minus 2L over 2. And if you wanted to put that all over 2, that'd be okay. It's the same thing. W's alone. Got it alone. I solved for W. I know sometimes you're used to like, well, W is supposed to be 6. A lot of times you don't know what it is. You just know that this will tell you W. And then later they're going to tell you, oh, by the way, S is 10 and L is 1. And then you can stick them in and figure it out. But you need to be able to solve and have something in the answer. Last thing, they could say, solve for W in terms of L and S. What they're saying is solve for this one, and L and S will be in your answer. So I'll do one like that. What's another true statement? Area equals 1/3 pi r cubed. This is the surface area of a sphere, I think. Okay? Solve for r in terms of a and pi. That just means a and pi are going to be in your answer. Solve for r. When I say solve for r, I want r equals. And when I say in terms of pi and a, it means pi and a are in the answer. Okay, your first thought should be, remember that thing I was just telling you earlier this hour? About how we don't like fractions? It's a lot easier if we can get rid of the fractions. What can I multiply by to get rid of the fraction? 3. So I can multiply by 3 on both sides. Why was that smart? No fraction anymore. 3a equals pi r cubed. Now, is r alone yet? No. So next time we get rid of the pi. Divide by pi. Divide by pi. Why? Because it's attached with a times. So now that's gone. R cubed is equal to 3a over pi. I'm getting close. Does anybody remember how to get rid of a cubed? Yes. Cube root is a good way to say it. Those of you that are really smart might know that we could put this to the 1/3 power, which is the same exact thing as cube rooting. And 3 times 1/3 will make it a 1, and this will be work. Otherwise, if you don't like this, then I can do that cube root thing, which is cube root this and cube root this. That's a cube root. Some of you might like the 1/3 power better, but a cube root and a 1/3 power are the exact same thing. Cube root of 3a over pi. I know some brains just exploded there. That's okay. All right, you're not going to see that one a lot. So, all right, let's go on. Literal equations where you have to factor to get the variable alone. This is the hardest kind. It's really not super hard, but it definitely involves a little stretch. If I asked you to solve for m, that would be fairly easy. You'd get rid of this a here, you'd subtract a on both sides, and you'd leave the negative m there, and then you'd divide by negative m on both sides. But if I asked you to solve for a lot of you would be stumped. I'm going to prove that by just saying, can anybody solve this for a? If you can, take a second, try it. Everybody write the problem down, at least. And if you can actually solve it, awesome. I'd love it. I bet you there's one person, maybe two. But the rest of you are actually going to learn something here that you need to know for Tuesday. All right. Anybody got any ideas? Okay then. Pay attention. Every one of you would have got that wrong. So let's fix that between now and Tuesday. Pay attention. If a has to be alone, do you get how it would be really nice if there was only one a? So to get it to be only one a, I'm going to take this and say, oh, there's a's in both of them. I'm going to factor that a out. When I factor the a out of this part right here and this part right here, what do I have left? What I'm trying to do here, I'm just going to go up to an aside for a second. Let's say I had this, 2x plus rx. Do you get that there's an x in both of them? And if there's an x in both of them, I can pull it out, and I'd put 2 plus r here once I took an x out of both of them. Do you get that? I factored it out. That's what I'm going to do here. I'm going to factor this a right here and this a right here. There's one in both of them, so I can factor it out. I take it out, put it in front, and then what I'm really doing when I'm factoring is dividing by that. And what is a divided by a? 1. What is ma divided by a? M. And it's a minus. There we go. Except it's 1 minus m. That's different. It's not 0 minus m, it's 1 minus m. All right, why is that just step really good? Because now a is alone, kind of. If I can just get rid of this part right here, which I can. Because how is it attached? It's attached with a multiply, so all I have to do is divide by 1 minus m on both sides. And this will cancel this, and a is alone. A is equal to 7 over 1 minus m. I know that since nobody got that right the first time, you probably are still not sure how to do it, so I'm going to show you another one. I bet you I picked up 10 of you just right there, but maybe I'll get the rest of you in a minute. Yes, ma'am? All right, let me show you what I did again. A minus MA, and when I took out the A and put it out here and put in 1 minus M, the reason I know that's right is, watch. This times this gives me my A, right? This times this gives me my A times negative M makes negative MA. You see it? I know it's right. Okay, so here's another one that's like that. P is equal to 4Q minus RQ. Solve for Q. The only way you can solve for something is if you get it down to only one of them. You got to get it down to just one Q. Q equals whatever. If you learned that factoring trick, you just took a Q out of both of them and put 4 minus R. How do you know you're right? You just multiply it back out. Q times 4, 4Q. Q times R, RQ. Yay, I did it right. Is Q alone yet? No, but I can get it alone really easy. Now all I got to do is divide by 4 minus R, divide by 4 minus R. Cancels. Q is equal to P over 4 minus R. Raise your hand if you had that one right. Ooh, it picked up way more than 10. You're quick learners. That's really good. All right, I'm going to give you one more without any help here. Y equals 6m plus xrm. Solve for m. Y equals, if you're solving for m, you factored the m out, and then you have 6 plus xr. Now, to get the m alone, I got to divide by 6 plus xr, divide by 6 plus xr. These guys cancel. Y over 6 plus xr. Raise your hand if you had it right. Awesome. Okay. Well, we have reached the end of what you need to know for today. I think that was, as I mentioned, you'd probably like today better because it's more in your wheelhouse. Probably better at this stuff. I have a worksheet for you. We're going to work on it for a while. This gives you a chance, if you really struggled on yesterday's, you can ask me questions individually. Like come up and say, I didn't get number 7 in yesterday's or whatever. You can ask about yesterday's stuff during the work time today. We are still going to grade that later. All right. That's all I got for the video for today.